Hello, everyone. We are working on an introduction to statistical methods and data analysis by Ott and Longnecker. We are in chapter 12, part 1 of the lecture notes. All right, so we've talked briefly about the multiple linear regression, how we have multiple x's for a single value of y, and we can write the fitted regression line with y hat equals beta 0 hat plus beta 1 hat x1 all the way down to beta k hat times xk. All right, our residuals are calculated by taking your observed yi and subtracting off your predicted yi. So this is the same as single linear regression, but in this case, we have multiple x's that we end up using to figure out what our y hat is for the ith person. Then we look at their observed yi and we just do that subtraction and you'll get the residuals. Okay, at the end of the day, we're going to sum up those squared errors. So, you have your data points, but instead of being in 2 dimensions like simple linear regression, now we're in k-dimensional spaces, and we have that line going through the k-dimensional spaces. And we're still going to minimize the vertical squared errors. So we're going to take our observation and we're going to subtract off the predictions and square them. This is called the least squares method, and essentially we're choosing those beta 0 hats up to the beta k hats so that our sum of squared errors is minimized. Okay, beta 0 hat up to beta k hat are the estimates of the parameters beta 0 up to beta k. In fact, these are the best possible estimates, right? They're the maximum likelihood estimates of these parameters. So remember that essentially this group, everything with the hat, these are our statistics. And the beta 0 to the beta k, these are our parameters. They are the slopes in our regression line, right? These are essentially the true slopes for all of our x's, and these are estimated slopes. All right. Good so far. All right, so if you're wondering, this is somewhat beyond the scope of our class, but just so that you have been exposed to it. So if you want to stop watching the video now, you're more than welcome to. But if you're wondering, how do we actually minimize the SSE? Essentially what we're doing is we're going to take the derivative of this equation with respect to each of the beta j's, okay? And once we do that, we're going to rearrange these normal equations and we're going to solve for this system of equations. Now, the reason why I say this is beyond the scope of our class is because A, this requires calculus, okay, to do all the derivatives and solving. B, at the end of the day, we're going to use computer programming to do this. So essentially you can use R, Stata, Python, whatever you prefer to get the least squares regression estimates. And so essentially, if you're interested in this type of thing, you could walk through the actual proof. But if you're not interested in it, just know that essentially we are minimizing the sum of squared errors. And at the end of the day, we're obtaining estimates for the beta 0 all the way up to the beta k. Those estimates are the beta 0 hats all the way up to the beta hat k's.